B equals what?
B equals sister plus 8 plus 3.
S plus 8. We'll say B for Barry and S for sister. I like to use variables that kind of match the names of people. Like I like to use X and Y. I would use B for Barry and S for sister. That makes more sense. Okay, so what does this mean? In 3 years, he will be twice as old as she will be then.
Means B plus 3.
So what does in 3 years mean? Is that plus 3 or minus 3?
Plus.
Okay, so we're going to go Barry plus 3. Because that means in the future, right? So Barry plus 3 will equal
S plus 3.
twice as old as she will be then. What does then mean? What does then and now mean?
3 years.
Now means what?
Right now.
Right now. Then means
3 years.
in the future. So if I give 3 years to Barry, I've got to give 3 years to his sister to be fair. So it's going to be twice his sister will be then. So plus 3. Does that make sense to you? I built that. So Barry plus 3, that's in the future, in 3 years. He will be twice as old as she will be then. The plus 3 takes care of the word then. Then means in the future for her too. It's going to be the future for her too, so in 3 years. Hey, can you guys solve the system for me without my help? Can you guys solve it? It's built for...
No, 13.
Elimination.
Is it built for substitution or elimination? How's it built? It's built for substitution, right? So you can plug this in and try and solve it. Plug it in right there and solve for the sister's age. Built for substitution, right? So S plus 8 plus 3 equals, what happens on the right side, guys? Distributive property, so would that be 2S plus 6? If you times them both by 2 there. So adding like terms, S plus 11 equals 2S plus 6. So minus S from each side. So 11 equals S plus 6. Then minus 6 from each side, right? So the sister's how old?
5.
5 years old. Sister's 5, and he would be what? 13, right? How would you check your work, guys, if you're taking a test?
8 years difference. 5
Well,
plus 3.
just think it through.
8 year difference.
How old is she going to be in 3 years?
6.
8. How old will he be in 3 years? Is he twice as old? That's what it's saying. In 3 years, he'll be 16. In 3 years, she'll be 8. And he'll be twice as old. So think what the problem's saying to you, what the problem means, okay? I say you check your work, make sure the problem makes sense to you. All right? Okay, this one, you're on your own. Work with a neighbor. Can you guys do it? Jennifer is 6 years older than Sue. In 4 years, she'll be twice as old as Sue was 5 years ago. Can you build it? Give it a try. If you haven't done it, work with the neighbor there next to it and try and build it. I need 2 equations built. See if you can build and solve it. This is on your study guide number 29. See if you can put that together. Did everybody get a chance to sign the roll today or mark it here? The roll stops over there. Check the roll today. Whoever has the roll, make sure it's close to the next table. Okay, so what was your first equation, Joe? What'd you write down?
First equation was J plus 6 or J minus 6.
J take away 6 equals S.
That's just like five.
Okay? You could also do J plus 6 equals S. They both be okay.
Wait, why?
Oh, wait a minute. Wait a minute. Yeah, it has to be this one, Joe, because older than means plus. Yeah, it has to be this one, because older than can't be minus. Does that make sense to you? That wouldn't quite work, yeah.
Okay, that makes sense. Okay.
Yeah, older than means you're older than somebody, so it has to be plus. No, wait.
Wait, but
Couldn't you do-
if Jennifer is 6 years older, then that means Jennifer
Right.
minus 6 years would equal.
Couldn't you do J minus S?
Yeah, you're right.
Yes, you can.
You can do J minus 6 equals S. Or we could do J equals S plus 6. I got mixed up, sorry guys.
Oh.
Those would both be acceptable.
Yep.
You can do J minus 6 equals S, or J equals S plus 6.
Oh, yeah.
They both be okay. Yep. Okay, Joe, good job. Okay, so in 4 years, what does that mean in 4 years?
Actually,
So J plus 4. In 4 years, she will be equal
S subtract five.
twice as old as Sue was 5 years ago.
2S subtract five.
So 2 parentheses S minus 5. Does that make sense, guys? So you can plug into J or plug into S, whatever you want to do is fine. So Jennifer is 6 years older than Sue, and then in 4 years she will be twice as old as Sue was 4 years ago, or 5 years ago. Do the two equations make sense to everybody how they built it? How the wording kind of helps us build that? Okay, try and solve that on your paper. So plug this in, try and solve it. They call these age comparison problems. I'm comparing ages here. I'm going to be kind of lazy and just sit here the whole period, is that okay?
That's not being lazy, that's being a teacher.
Does that mean a teacher, Todd?
Yep.
Can teachers be lazy too?
Teachers are never lazy. They're always lazy.
You guys know what this is in drawing?
Thought.
I gotta make it a little bigger. That's not big.
It's an A plus cloud.
Make it a little bigger so it'll fit. You know what that is?
An am tree.
It's an ambush.
Oh.
It's an ambush.
That looks more like an answer.
Is that an am tree? Bushes are too big, right? That's an ambush.
That's pretty good, that's gross.
You know what this is, Ty? I can't draw today very well. You know what that is, you guys?
What? I can't even move.
That's a worm crawling over a razor blade. Sorry, guys. Is that a bad visual? Get myself fired here, not careful. Does anybody have the answer for us?
Yes.
Emma, what'd you get? For number 29, what'd you get?
I got 20 for S and
26 for J and 20 for S. Y'all agree with that? Good job. If you missed it, keep trying. So, sister's 20 and or Sue's 20 and Jennifer's 26. Nice. Good job, guys. Okay, turn the page. Let's keep going. We're not quite done yet. Okay, let's move on. You go to question 31. Now, is that on the same page or a different page?
It's 25.
Go to 31. We actually did these last week on right before we went home, remember? I did one example of it right before we went home last Thursday. Let's revisit it. Okay, Tom has a collection of quarters and dimes in a jar. The total value of the coins is $6. There are 30 coins in all. How many of each type does she have? She has, it's a he.
Wait, Tom is a she? Tom!
Tom.
You also need two questions that are exact same, so Larry and Barry.
Did I?
26.
Let's change the word he to, or she to he. Sorry, guys.
Wait,
That's
just
a
a
kind of typo there.
Yes.
Tom is a girl today, so. So you guys, what you gotta do here, you first have to say quarters plus dimes equals 30.
Yeah.
Just tell me how many coins you have, okay? That's all. Actually, I'm gonna write that a little bit more spaced out. Let me write it. So quarter plus dime equals 30. Does that make sense? The next equation tells me their monetary values. So how much is a quarter worth?
25 cents.
So 25Q plus, what's a dime worth?
0.130.
Okay, no decimals, just go 10D. Let's go decimal free, okay? Equals 600.
Yes.
So instead of going 0.25 and 0.10 and 6.00, just write everything in terms of pennies and it makes it easier. You know what I mean? Just go 25Q, 10D, and 600. So lose the decimals. You know what I mean? It just saves time.
Thank you.
Make it decimal free. Now, is that vote for elimination or substitution?
Looks like elimination.
Elimination, because everything's lined up in columns, right? This is classic elimination. So here we go. Put a negative 10 there. A negative 10 there. And times this by negative 10. If I do that, what do I accomplish, guys, if I do that?
You make it so you can eliminate the D's.
Yeah, the D's cancel, right? Good job, Joe. So draw a line.
Makes actually a lot of sense.
Yeah, by doing negative 10, guys, it makes the D's cancel, okay? So, what's your Q total?
Makes a lot of sense.
15 quarters equals 300.
Yeah, I tell the jokes here, okay? Ty, not you.
15 quarters equals 300.
Okay, so 15Q equals 300. Does the D's cancel? You divide that, gives you what? What does that divide give you? Is it 20? Yeah, 20, right? Divide gives you 20. How would you find the number of dimes, you guys? Quickly.
It's 10. Because 30 minus 20 is 10.
Remind me your first name.
Joe.
Joe, yeah.
Where do you just type 20 or 5?
Yeah, just go, the quick way is to go 30 minus 20 is 10, right? Yeah, Joe, good job. These two combined have to be 30, okay? But this kind of math takes the guesswork out of it. You're not trying to do it by trial and error. What you can do, but it's irritating. Okay, Joe, or Ty, tell the joke. This problem makes
A lot of sense.
a lot of sense, right?
I already said that.
Ty, you're trying to coin a phrase here or what?
Oh.
Joke's horrible. Okay, ready? So on your own, you guys tackle it without my help. So you got Christy with a 35 coins, quarters and dimes, worth $5.75. See if you guys can build it and solve it. Collection of coins worth 5.75. Quarters and dimes. Oh, excuse me. You guys hear Tanner Manning got hurt Saturday in the football game?
Really sweet.
You lose quarterback.
Yeah, I heard about it.
Bummer, huh? I'm a BYU fan. You a Utah fan or something? Well, you're a BYU fan, of course. sure not. Rise up. What? What, Josh?
If TJ's come back in, they would have totally lost.
I know.
Their backup really sucks.
He didn't do very well. Josh, you lucked out.
We never
Were
really.
you at the game, Josh?
Oh, no.
Yeah, I was at the game.
I just watched it.
I had a cougar dog and a cougar tail. You know what a cougar tail is?
It was really good.
It's a 2-foot maple bar. Oh, it's so good. It's so bad for my diet. It's so good. You like cougar dogs? They're pretty good too. Okay, Nathan, can I call you? What's the first equation, Nathan, gonna look like? Can you shout it out? You just go Q plus D. Q plus D equals 35. Just tell me how many coins you have. Yeah. Just write down what you have, okay?
Well, I just think we're at it.
Okay, Summer, can you give me the second equation of that one? What would that look like?
Yeah, and it's 25Q.
Okay, 25Q
Quarters, that's
plus
plus 10,
10D equals
575.
575. Does that make sense, you guys?
Yeah.
The first equation tells me how many coins you have. The second one tells me what they're worth monetarily. Okay, it's built for elimination, right? I would put a -10 there, a -10 there, and times that by -10. That'd be a good way to do it. Okay, did you guys get it figured out? Did you get it, Ellen? Not yet. Okay, keep going, keep going. Do -10, -10, -10. -10, -10, -10. Hey, Emily, how do you capture a unique dog?
You can up on it.
You cut it.
How do you capture a unique dog? How do you capture it?
You need up on it.
Unique up on it. How do you capture a tame dog?
What?
The tame length.
That's pretty smart.
Jokes are really bad.
I've actually never heard that.
Yeah.
No, it's not.
Ellie, sorry, Emily. Ellie, sorry, Ellie. Everybody's name is safe there. Oh, I'm sorry. Did you guys do it? So 15Q equals what?
Equals 220.
225. You're just adding these up. Add. Divide gives you what? 15. So using basic logic, what is 35 minus 15? 20. Guys, if you're taking a test, how would you check your work on this problem if you're taking a test?
As and dimes 20 times.
Yeah, you say, well, how much money is 20 dimes? How much money is that?
It's $2.
$2, right? How much money is 15 quarters? How much money is that?
$3.75.
Okay? If you add those up, you can check your work pretty fast, right? Well, I would say on a coin problem, it's very easy to check your work. Just make sure it makes sense to you mathematically. Okay, we got 4 problems to go. We're ready to have a homework before the weekend. We'll fall right
Before the blue long weekend.
Okay.
3 days.
Okay, turn the page. Go to problem 34, guys. Okay, we have Jake. He's going to invest some money in the bank.
How on earth did he earn that much money?
$20,000. How do you rob the bank? So, he's got a rich uncle, okay? He's going to put $20,000 in the bank.
He's kind of not very smart.
Okay, one account pays 8%, one account pays 6%.
I would just do the 8%. And that's
You know, guys, if you put money in the bank, what does the bank pay you for that?
like 0.0%.
What do you call it? What does the bank give you if you put money in the bank? Interest, right? And banks pay terrible right now. They pay horrible.
Like 0.20.
It's like a 0.5%. It's horrible.
It is like 0.2.
13 cents, that's not pretty good. Why do you think banks pay so little? Do you guys know? Why do banks pay so little? Well, because they're safe, right? Because they're backed up by the government, so they're safe.
Just if we want to make money.
Well, true. But because banks are pretty safe, they pay low.
That's not.
If you put money in the stock market, it pays better. You know why? Because the stock market is what? Riskier. The stock market takes a bit of guts to invest in the stock market because you can lose your money or gain money. Because the risk is higher, it pays better. Because banks have no risk at all, they're pretty safe, they pay low, okay? When you guys get older and have a job and a family, you'll learn that. The higher the risk, the more money you can make, but also you can lose your shirt, so you have to be careful. But because banks are pretty safe, you know.
We're like freezing your
Yeah. So this problem is not real life at all, okay? Just pretend it's real life, but it's not.
I wish they
So one account pays 8%, one account pays 6%. If Jake earned this much money in interest during the year, so 1380 is what he earned, how much did he invest in each account? Now, this is very similar to a coin problem. We have to do some labeling. I'm going to label the letter A as 8%. So on your paper, label this with me, label it. I'm going to label letter B as 6%.
Why don't you do?
We need to label the accounts so we know what we're doing. Okay. It's basically, guys, a big coin problem. It's a big coin problem. So you first say A plus B equals what?
1, 3
Equals 20,000.
Yeah, how much you put in the bank? A plus B is $20,000. Tell me how much you invested. Okay? The second equation is going to be your interest rates, what they're worth monetarily. So we got to go back to decimals. A is 0.08. Put that in decimal form. So put 8% as a decimal. And then B is 0.06. So put B in decimal form. This has to equal how much Jake earned during the year, so 1380. It's built exactly like a coin problem. It's very similar. A plus B is 20,000. Tell me how much you put in the bank. Then tell me your interest rates. A is 8%, B is 6%, and it's 1380. Did you guys see the similarity to the coin problem? It's very similar. It's built almost the same way. But the numbers are bigger, right? Now, are you guys big fans of decimals?
Yes.
No.
Actually.
I am not.
Prefer numbers.
So, remember our decimal trick from chapter 2? Yeah. I'm going to times this whole row by 100 to get rid of the decimals, okay? So it's going to be 8A plus 6B equals 138,000. Guys, what is the one negative to that trick? What's the one negative part of that trick?
That number is now.
The numbers are huge, right? Which is kind of a bummer. But I still think being decimal free is better than having huge numbers, in my opinion. So I would say get rid of the decimals. Scratch this out. I guess scribble it out with your pencil. So I would say lose the decimal. That's kind of irritating.
Now it looks like a circle.
So cross off the decimal equation, get rid of it. Okay, you guys ready? Okay, so what number is going to go in front of the A this time?
-6.
Let's go -6. So -6 there. -6 on the B. Let's force the B's out. Then times this by -6 would be what? Negative
120,000.
120,000, right? Does that make sense, guys? So -6 on the A, -6 on the B to force the B's out, and then times that by -6. So we're trying to solve it. So it's going to be what? Add the A's up. 2A equals what?
18,000.
Yeah, that's 18.
Right, 18,000, right? That's okay. So what is 18,000 divided by 2, guys?
9,000.
9,000, right? Let's put a dollar sign there because it is a money problem. Put a dollar sign. Okay, what's the B account going to be, guys? What would be the quick way to solve for the B account?
It's 11,000
Right, just go 20,000 minus 9,000 for the B account. That's a good way to solve it. Remember, these combined have to be 20,000, right? So it's be 11,000.
We're right, Phil. How many did you do that?
Now, is that a problem you can do in your head by trial and error?
No.
Probably not. The numbers are a little too big for your brain, probably. That's probably not a trial and error type problem. So the process is important here, okay? But it's built like a huge coin problem.
What? How is that even possible?
That'd be tough to solve in your head, right? It'd be kind of too hard. Yeah, Ty?
How does he make more for the 6%?
Well, he put more in the 6% account than the 8% account, which is kind of dumb, right, Ty? This guy's not too bright, but he just did that.
Okay, makes sense.
Maybe because that account's a little safer, right?
Yeah,
So.
Okay.
Okay, we got only 2 problems left. You guys are awesome.
Yeah,
Your brains handle 2 more today? We're going to mix some chemicals, right? We're going to mix some alcohol.
Yeah.
You guys want to hear a funny story? Well, when I was in high school, I had a crush on this girl named Clara Kemper. She was really cute. I had a crush on her. We had chemistry together, a chemistry class, okay? And I was her lab partner. I was so stoked. And I was too shy to ever say I had a crush on her. So we were lab partners. And we're trying to do this like chemical experiment together. So we're talking, you know, and trying to do our lab together. I was like 16. I was in high school. Too shy to talk to a girl yet, so I was kind of a nerdy, shy kid, okay? Is that hard to believe knowing me now, right? Ty, what do you think? Ty's like, Mr. I can believe it. So I put the 2 Bunsen burners under I put the 2 test tubes under the Bunsen burner flames, right? Yeah, they're supposed to both be heated under the Bunsen burner flames. This test tube I put a little cork on like we're supposed to. We weren't supposed to cork the other one. Only one got the cork. One just got the chemical flowing into it, no cork. I stupidly corked both test tubes.
Awesome.
Something bad happens, okay? The pressure builds, right? So Clara walked over to sharpen her pencil by the door, and the one test tube shot out of the clamp and hit her in the back of her shirt and exploded. She never talked to me again. So we never became friends. Isn't that a sad story? I had a super huge crush on her. Hope she's okay. She actually's okay. She's okay. She lived. It's embarrassing. I was the biggest nerd on the planet. It's okay because I married a great high school named She says okay. I was a nerdy, you know, high school kid. Okay, ready to mix some alcohol together?
No.
Okay, here we go. So this is going to be this drawing's our 50% alcohol. And this drawing here is my 20% alcohol. We're going to mix these up and make a big mess. And I want to get out of this mess 18 liters. And I want the purity to be 30%.
Oh, that's a percent sign.
So we're going to mix this mess. We're going to mix it. We're going to mix this purity to this purity. And I want 18 liters of this purity. Does the problem make sense to you? What we're going to do? We're going to take these chemicals right here and shake them up and mix them up. And take these and mix them up and kind of shake them all together. And I want one big batch of 18 liters of 30% purity. Okay? They call this like alcohol's purity, like how pure it is. Okay? None of you guys drink beer, I hope, right? Beer contains alcohol, and it's about 3% pure. So beer's alcohol is not that pure at all. But this is like 50% pure and 20% pure. It'd be like rubbing alcohol. It'd be very strong. It'd probably kill this one. It'd be very, very good. Okay, so we have to assign things. So I'm going to assign the letter A to be 50%. So let's assign this on our paper. I'm going to assign the letter B to be 20%. Let's assign these letters correctly. I got a question for you guys. Does it matter how to assign A and B initially? Does that matter at all? Not one bit. Not one bit. Just assign them. So who can guess the first equation? I'm curious. Who can guess the first equation? Can I call somebody? Brielle, shout it out. No guess? Okay, Joe?
A plus B equals 18, right?
Joe, you are the man.
Good job.
A plus B is 18. What does the first equation tell me? How much you want to make, right? What you're making here? 18 liters of something? Okay, tell me how much you're making. A plus B is 18. The second equation tells me how pure things are. Okay, how pure is A? So 0.5, right? Make these decimals. How pure is B, guys? 0.2. The last number is kind of tricky. It's not given to you directly. You have to times these two numbers together. You got to go 18 times 0.3 to the last number. So this number becomes these two multiplied on a calculator. What's 18 times 0.3? You guys have your phones with you? Type it in on your phone. What's 18 times 0.3? 5.4. A lot of kids miss the problem right there. Because you have to go the number of liters times its purity. Does that make sense to you intuitively why that would make sense? Because guys, look at it. Look what I'm doing here, okay? This term is purity times A. This term is purity times B. This has to be purity times the whole mixture. So the equation makes sense. Does that make sense to you? Purity times A, purity times B, purity times the whole thing. 18 times 0.3. That way the equation makes sense. You're going purity times A, purity times B, purity times 18. Okay? You guys fond of decimals? I'm not. Let's get rid of them. How are we going to do it? Right, Emma. Times it by 10. Let's do that.
I am not Emma.
Well, I was talking to Emma Summers. Okay, times it by 10. Right, guys? Okay, you ready? So here we go. This is going to be 5A plus 2B equals 54, right? Okay. Cross this out, and then can you guys solve it for me? Without my help, try it. Try and solve for A and B without my help. Try and solve the system, okay? Who said to be or not to be?
No, Shakespeare, actually.
Was it Hamlet? Hamlet and Shakespeare?
So Shakespeare.
To be or not